Alright, SL1 fans, you are back with Mr. Jolly. Today we're going to start talking about 2.5, which is a composition of functions, but I call it the function inception, because if you saw that amazing Leo DiCap movie, it's all about like dreams within dreams, and today's all about functions within functions. So, before we get into functions in functions, we're going to talk about just a function in general. You need to think of them as kind of like machines, like a machine that does something. With these machines, you drop numbers into them as inputs, and then numbers come out of them as outputs. So, in this particular example I made up, f of x equals negative 2x squared plus x. Like, let's say I drop in a 2 into this function. So then to find f of 2, you would do negative 2 times 2 squared plus 2. That's too many 2's. I should have chose a different number. So this is 4 times negative 2, which is negative 8, plus 2, which equals negative 6. So f of 2 is negative 6. So if I dropped in that negative 2, out of it would come a negative 6. Input and output. Now, let's say you linked two of those functions, like you took an f of x and a g of x, and whatever you feed in to f of x, the input from f of x is going to get outputted here, but then that's going to become the input for g of x, and then go crunch, crunch, crunch through the g of x machine, and then it's going to spit out something here. So, for example, let's say I put in, I want to know what's going to happen if I feed a 0 into this. So first we'd have to put a 0 into f and then take that output and put it into g. So really it looks like this, g of f of 0. Look at it from the inside out. First we're going to put a 0 into f of x, and then whatever that is we're going to put as an input into g of x. So I'll keep the g around it. This is negative 2 times 0 plus 5. So then the goose egg kills the negative 2. Gets rid of the negative 2. Sorry, such a negative language. So then this is g of 5 so far. But then you got to take that 5, which was an output from f of x, and make it an input in the function of g. So in the function of g, the input is multiplied by 3 and then subtracted by 2. So this becomes 3 times 5 minus 2, which is 15. Take away 2 is 13. So g of f of 0 is 13. Oh, so the visual on that, I put in a 0 right here. That's a 0. And then out of it comes a 13. Because it went through the pipes. Now, what I just did when I linked these two functions here is I essentially made a composite function. Composite functions are a function within a function. It's a dream within a dream. So we're not always going to write it like this, where you can actually see which function is inside and outside. Your book is going to write it like this. Fog of x. Fog of x means g of x is inside f of x. Actually, usually I think your book usually puts parentheses around it like this. So just read it sort of right to left, that this is the inner part, and then this is the outer function. So you can have any sort of order with these. It can be fog or it can be goff here. So g of f of x means f of x is inside of g of x. Remember, you read it right to left. F of x, then g of x. So, quick example. If f of x equals 3x minus 5 and g of x equals x squared plus 2x minus 1, we're going to find, and h equals negative 3. We're going to find goff, which is g of f of x. So that means putting f of x into g of x. So here, I'll write it out this time. This means g of f of x that means taking f of x and putting it into the input of g. Now notice with g that the input is input squared plus 2 times the input. So in those spots here and here, we're going to replace those with 3x minus 5. So we get 3x minus 5 squared plus 2 times 3x minus 5 minus 1. Then I got to clean up a whole bunch of stuff. Here I'm going to have to FOIL, or, distribute, because that's actually 3x minus 5 times itself. So I believe that's 9x squared. Oh, I'm going to be a bad math teacher. I'm going to skip steps in my head here. Minus 15x. Well, I guess I'll write out more steps than I normally would. Minus 15x plus 25. And then here, we're going to distribute the 2. So we get plus 6x minus 10. And then the minus 1 is still hanging out. Now I just have a bunch of apples and oranges. I see there's only one x squared, but there's a bunch of x's. So the negative 15x, negative 15x, and 6x can be negative 30 plus 6 is negative 24x. So this equals 9x squared, negative 24x, and then go different highlighter, 25, negative 10, negative 1. That's negative 11 plus 25 is what? Oh man, brain's not working today. 14? Yeah, 14. And then that's as simplified as it gets. So that is g of f of x, and I'm going to leave it right there. Now, this problem on this side, f of h of x, let's go back to my blue highlighter. This one seems kind of tricky at first because h of x is kind of a weird function. It's just h of x equals negative 3. Remember that you read this right to left, and this means f of h of x. So the h of x at all times is just negative 3. It's a horizontal line. So this is just f of negative 3. So in that case, all you do is feed negative 3 into the input up here of the f function. So we get this, well, yeah, these are all equal. This is equal to 3 times negative 3 minus 5. So we get negative 9 minus 5, which is negative 14. And boom, that one is done. Now, 2 more examples using those same functions. F of g of negative 1. What this means is putting negative 1 into g, then whatever that is, you're putting it into f. So, let's see if I can write this all in one line. G is x squared plus 2x minus 1. And f is 3 times something minus 5. So, it's going to be 3 times something minus 5. That's the 3x minus 5 right here. That's the f function, the outside. But then inside, we need to put g of negative 1. And g is x squared plus 2x minus 1. So it's going to be negative 1 squared plus 2. Oops. 2 times negative 1. What's the very end part? Minus 1. Whew. Okay. Now it's just all numbers, so we got to play cleanup. And let that 3 just chill on the outside. Inside, negative 1 times itself is positive 1. Minus 2, minus 1, minus 5. Inside here, this is negative 2 times a positive 3 is negative 6. We get negative 6 minus 5, so I believe this is negative 11. That's f of g of negative 1. Now, part D, party time. F of g of x. Fog x. That means taking g of x and putting it into f of x and then whatever that is, also feeding it back into f of x. Oh my gosh, this is true inception. Dream within a dream within a dream. So let's see if I can do this. F of x is 3 times the input minus 5. So the big outside is going to be, gosh, let's see here, 3 times something minus 5. Now the next one is another f of x, so that's going to be another 3 times something minus 5. And then this very inside spot is going to be g of x, which is x squared plus 2x minus 1. So x squared plus 2x minus 1. So here, I'll use a different highlighter. This is g of x, f of x with g of x inside of it, and then another f of x with f of x of g of x inside that. Gnarly. Let's play cleanup. I'm thinking let's distribute this 3 inside here. First up. So outside 3 can chill. This is 3x squared plus 6x minus 3. And then that minus 5 is still there. Then that 3 is still going to chill because I'm going to combine this negative 3 and negative 5 like terms. 3x squared plus 6x minus 8. Then I got to distribute again, so we get 9x squared plus 18x minus 24 minus 5. One last cleanup. 9x squared plus 18x minus 29. And boom, we are done. Big one, for sure. All right, last problem. We got 2 new functions. We got an f of x equals the square root of x, and we got a g of x equals x squared plus 3x. First up, we are going to find gof x, which is g of f of x, and then we're going to state its domain. Okay, here we go. Well, this means putting f of x into the inputs for g of x, which would look like this. The square root of x squared plus 3 times the square root of x. So that's g of x, which is input squared plus 3 times the input, but each input is this, square root of x. Now, square root of x and the square cancel each other out here, so we just end up with x there, and then this part you can drop the parentheses, and this is just 3 root x. So that is g of f of x. Now the domain of this guy, really the only problem is this right here. This is where your eyes should go to immediately. Anytime you have a square root in an equation, the inside of the square root cannot be negative because there is no answer to the square root of negative numbers. Like, what's the square root of negative 9? People are like, oh, is it like 3? No, because 3 times itself is positive 9, not negative 9. They're like, oh, what about negative 3? And you're like, no, negative 3 times itself is also positive 9. So there's no, actual square roots of negative numbers, at least within the subset of real numbers. IB doesn't care too much about imaginary numbers, so everybody rejoice that we don't go too heavy with I and things like that. So, you guys, the domain is that x, well, that's not the right tool, has to be greater than or equal to 0. Remember, you can take the square root of 0, that's fine, but you can't do any negative numbers. So x has to remain positive. I'll throw a little IB notation in there for you too. Let's see, it includes 0 and goes up to pos infinity, but you can never get to infinity, so open bracket. Last question, find fog of x and state its domain. Let's see, fog means putting g of x inside f of x. So we're going to put x squared plus 3x into the square root of x. Oh boy, this is going to be fun. Okay. Fog of x is taking g of x, which is x squared plus 3x, and putting it into g of x. This is x squared, the big square root of x squared plus 3x. Now, you guys, that is fog of x. That part, it can't be simplified. You can't. A lot of people want to cancel out the square root with this guy right here, the square, but it does not work like that. You can't break little parts apart like that. That's not a property. Like if it was just the square root of x squared, that'd be fine. But this 3x really messes it up for us. So it's as simplified as it's going to get. Now, the domain is where this gets a little tricky. You guys, the inside of the square root, this x squared plus 3x, cannot be negative. So I set up a little inequality saying that x squared plus 3x has to be greater than or equal to 0. I'm not sure how you guys solve this in AGS. There's a few different methods, but I'm going to teach you one that I've come up with over the years called zone testing. First, you kind of pretend that it's like an equal sign, that you're actually solving x squared plus 3x is equal to 0. Now, this side is factorable. It's x times x plus 3 is equal to 0. So then, if you have two parentheses being multiplied to get 0, the only way to multiply two things to get 0 is if one or both are 0. So you actually split this and say x is equal to 0 and x plus 3 is equal to 0. So if I were straight solving, it would be x is equal to 0 and x is equal to negative 3. But I'm not actually solving an equal sign. I'm doing an inequality. So here's what I want you guys to do. You draw out a number line. On that number line, you put your two answers, which are 0 and negative 3. Negative 3 should be on this side. 0 should be on this side. Now, we are going to pick three numbers from the three different zones. This zone, and this zone. You can literally pick anything you want, but I'm going to keep it small. That's negative 4, and in between negative 3 and negative 1, I'll pick negative 1, and then on the other side of 0, I'll pick 1. Then you have to test all three of these in your inequality that you're trying to solve. Because remember, the big point of all this is we're trying to keep that square root positive. So you feed each of these numbers, the negative 4, the negative 1, and the positive 1. I don't like those colors. The negative 4, the negative 1, and the positive 1 into the inequality. So let's test negative 4 first. Negative 4 squared plus 3 times negative 4 is greater than or equal to 0. This becomes 16 minus 12 is greater than or equal to 0. So then 4 is greater than or equal to 0. And then you ask yourself, is that true? Is 4 greater than or equal to 0? Clean that up for you. Yes, 4 is greater than or equal to 0. So this is a check. Yes, it worked. So I know that this zone right here is part of the answer. If you throw a negative 1, this guy, into here and here, like we just did, and you test it, I'm not going to go through it with you guys because I'm a little long on this video, but you get an inequality that's not true. I think you get 1 minus 3 is negative 2. So when you plug that in, you get negative 2 is greater than or equal to 0. And then we say, frowny face, no. So this area does not work. This is not part of our answer. Nope. If you plug positive 1 in there, I'm pretty positive that this does work. So our final answer for the domain of this awful long problem is that this is part of the domain and this is part of the domain, but the area in between is not part of the domain. So let's write that two different ways. That means the domain. X is less than or equal to negative 3, and x is greater than or equal to 0. Interval notation with IB would be negative infinity all the way up to -3, including it. And then you would have to unionize. You guys ever seen that symbol? Including 0 up to positive infinity, but you can never get to infinity. So that's what the IB interval notation would look like. You guys, I apologize, this was long. It's a kind of a complicated section. Also, this was only part of 2.5. We're going to finish up 2.5.